Hi children, we are going to discuss in the relativity the most important topic, Lorentz transformation. What is this Lorentz transformation? You might have listened that Galilean transformation. Transformations are nothing but the expressions which we are using for the equations to tell a relation between the two quantities or two entities. Okay. Now here Lorentz transformation which we are discussing, that a Lorentz transformation is a mathematical method of relating quantities between inertial frame of, while it utilizing with respect to special theory of relativity. Okay, when we are entering into the special theory of relativity, here time and space are variables, remember. Okay. Whereas in a previous Galilean transformation, time is a absolute. So since time and space are variable, then velocity of light takes place into the role in this. How does it takes place the role? How it is intervening in the equations, that we will understand here. First of all, basically, if we see that a Lorentz transformation, how does it takes place? For example, if you are considering two inertial frames, okay, you know that inertial frame is the frame which obeys the Newton laws. Okay, nothing but which we are there at present. Non-inertial frame which is not obeying, which exists beyond the space, you can take it. Let us say two frames S and S dash. Okay, S I am giving as a inertial frame, S dash as a non-inertial frame at time t equal to and t dash equal to 0. That means both are at the same origin of time. These two frames are superimposed initially, means they are on each other. Now let us say first case, if we discuss, you are seeing this first diagram, right? In this case, S and S dash, you are seeing Z Z dash, X X dash, Y Y dash, means they are superimposed, and that means within a frame there are the two frames are there here. Now from this origin I am taking S is at rest, S is at rest, S dash is in the motion. So S dash is moving from S to certain distance. Now how much it has moved? Let us say it has moved x distance, it has moved from here to here in positive x direction. So this is, if you are taking x dash, it has moved in the sense, and this part up to here I am taking the velocity of the frame and as well as the time taken by the frame I am taking with respect to the origin. So I can write the equation for this. The frame which has moved with respect to the S frame, the S dash which has moved can be written as, can be expressed in the form of equation. Normally we have discussed in linear physics and linear mechanics, position, velocity and time we will write x equal to v into t. But here with respect to another frame we are writing, so therefore x equal to x dash plus vt. I said this is x dash plus vt dash. V is the velocity of the frame which is moving right side here. Okay, here why I am mentioning the right side, in the sense, since you are taking right side of the coordinate x axis, we are taking that, so positive we are taking here. Okay, and the time taken by the frame s dash frame is t dash, right? So since with respect to light or observation we are taking here the length contraction, however length contraction also takes place here, because any object which is moving in the space, in the sense horizontally, if it is go longer distance, it appears little smaller. Okay, so that I am taking as, this is a one constant I am taking, that I am giving as a length contraction. Okay, first initially. So now how does length contraction is useful, how this factor is useful, how this factor is intervene here velocity of light. Okay, that you will get to know. Now this has moved along horizontal direction in x coordinate direction, so I have written, but in y direction nothing has moved. In z direction, it's remained same, nothing has moved. So I can write this equation as it is, x equal to gamma into x dash plus vt dash. This is the first case we can relate and we can express the Lorentz transformation. And now the second case, if you see here, what is this second case? Of course, the movement is relative. It can be anything. S can be moved or S dash can be moved with respect to each other. Now, what I am doing here, S is in the motion, S dash is at rest. So when S is moving with the same velocity V but left direction and S dash is at rest. Now in this case, if you see that with respect to S dash, we are describing the motion of S, right? So therefore the equation I am writing here to here, the distance which has moved x, okay, here to here it has moved x, and the point wherever this frame has moved inside that it is, I am writing vt. Okay, see, since this is a s frame, so time is t here, so that can be written as x dash equal to x. Okay, now this x is moving in this direction opposite to the, means from the original position is moving in negative direction. So the x direction whatever it is there, that minus I am writing vt. Okay, vt. So that is x minus vt I am writing. Of course, gamma is a factor which is affecting with respect to the velocity of light. Here initially we are considering as a contraction since it is moving away. Obviously, vertical direction the same, y dash equal to y, whereas previous case y equal to y. And in third case z dash equal to z, okay, whereas previous case z equal to z dash. Now, if you move the next case, if at time t equal to t dash equal to 0, in this case, let us say a photon is a light particle of light leaves the origin with in the same frame. Both the frames are there we have. So, whenever it leaves the light from the both the frames, it travels with the velocity c. Normally, light moves with the velocity speed. Now, within this frame S, if you see within the frame of S, it travels a distance x equal to ct. Means since it is a S frame, x is a motion or change in the position equal to c into t. Okay, t is a, with respect to S frame, c is a velocity of light, v into t, nothing but. So the same thing if you take up in the S dash frame, that is x dash equal to ct dash, we will write it ct dash. This we are expressing, this ct means in the time frame, the same transformation we are expressing in the frame of time. Let us say ct can be written as equal to c t equal to gamma into, in a previous case what we have written, gamma into whenever the light has moved from the frame, in a first case gamma into x dash plus vt dash we have written, means the light has released and moving. Okay, so gamma into x dash plus vt dash. Here this equation we can also rearrange that, gamma into x dash, no, x dash equal to ct dash, right? So ct dash I can substitute plus vt dash. Therefore t dash is same, so I can take it common. Then that can be written as c plus v. Here velocity of light as well as the velocity of the frame you can take of here v, which is released from the first frame. Now the same thing with respect to ct dash, means the light which has delivered in the frame 2, okay, I mean dash frame, equal to gamma into x minus vt. Okay, here the light has released, that means from there to in left direction s frame is moving, that is equal to, this is moving with respect to s dash, so gamma into ct minus vt, where ct is x we can write up. So that x if you are substituting, means x equal to ct we substituted, t we are taking a common, so gamma t into c minus v we have written. So ct dash equal to gamma t into c minus v, where ct equal to gamma t dash into c plus v. Here you can notice these are the two equations in terms of time frame. In terms of time frame, this equations also further you can make it as a time as a subject here t dash, and you can send the c this side. Whenever you are sending the c this side, then this equation also can be rearranged. T dash equal to gamma into t, and c by c is 1 minus, you can write off v by c when you are multiplying inside. Okay, this is t dash equation you can write, and here also t equal to, you can write as gamma into t dash, therefore c get cancelled. I have 1 plus v by c I can write off. Here 1 minus v by c, here 1 plus c by c. Means this is the time with respect to the, for the, with respect to the s frame, this is for the s dash frame. Okay, now these time equations also most important in solving numerical when an object is released or moving with respect to the inertial frame of s and s dash. Okay, this is one more case of transformation of equations, especially Lorentz transformation, the time functions you can understand from here. Thank you.